Good afternoon, everyone. It is day 5 of the 10-day EOC review. Today you're going to be looking at verbal descriptions. And interesting, I thought this was supposed to be linear functions. Yep, of linear functions. There you are. Right. Different ways to represent linear functions. Algebraically, tables, with graphs, or with verbal descriptions, meaning stories. Right. So several different ways that you can represent a linear function. Right. Check this out. So what do you need to know about linear functions? Well, linear functions, right, can be represented in several different ways, which includes tables, graphs, equations, and even stories. A story could be in a linear function, right? It could be a linear relationship. So we're looking at linear functions. And something you also don't know about linear functions is that linear functions always look like a line, either going up or going down, but either way, it is linear. This is, um, right, a linear relationship because it is a line. And also, further note that all linear functions have a parent function of y equals x. So just a backstory there also. Oh, but wait, there's more. Linear functions also have another thing. They also always will have a slope and a y-intercept, right? A slope and a y-intercept. Generally, sometimes, most times they tend to look like in this format. It's not the only format that they look like, but this is generally be the same usually. Where slope is this guy. Oops, actually, you go right there. Let's try that again. There you go. There you go. So slope is that guy, and the y-intercept is whatever this number is. So example, if I write the equation y is equal to negative 4x plus 2, the slope is negative 4, right? And the y-intercept is 2, where slope stands for your rate, right? That's what it is, your rate. And y-intercept basically represents your start. Okay, well, that's a lot there to cover, but basically it's a lot about linear equations in a ballpark general summary of what we've done this year so far. So let's look at the very first problem. Create a data chart for the total late fees Mark will pay for every day he is late with 4 movies. Well, unfortunately, I kind of forgot about the problem, so let me go get it real quick. It's over here. Ah, here it is. A movie rental kiosk charges 75-cent late fee per day. That's a, give me right there. Per movie. Ooh, my. Looks like we're going to do something here. He rented 4 movies. Let's see what it says more. Oh, it's kind of moving with it. All right, make a graph, a chart, and so on to show the relationship between the total late fees. This looks like it's an important item. And what's the other guy? The total late fees. Mark will pay every day if he's running retained movies, write a function, so on and so on. All right, let's get this done. But basically, we got the most important part of it. He's paying 75 cents late fee per day per movie. Well, let's think about it real quick. He rented 4 movies. Right? That's a gimme. So this part right here that I'm thinking about, like, so what is the slope referring to? This part's no longer null and void. All we need to know is that there's 4 movies going on, right? And if you have 75 cents late fee per day per movie, that means you're going to have 4 of these late fee charges, right? 4 75 cents late fee charges, right? This one really try to confuse it. So there's no y-intercept on this one, or at least the y-intercept is basically 0. It's just the 75 cents late fees, okay? So let's go through these. Now don't forget that there was 4 movies total, 4 movies. And since there's 4 movies, right, at 75 cents a piece, right, you're going to have to multiply that. That means every single day, because he's had 4 movies out, this guy's getting charged. That's 20. Actually, let me do me a favor. I'm going to switch these two. I like it better when that's over there. So there we go. I like it better when the bigger number's on top. Makes it easier on me. 4 times 5 is 20. 4 times 7 is 8. That's 30. Oh, I shouldn't do that. Drop down the decimal. I got 3. So basically, it's $3, right? That is the fee per day. Fee per day. Fee per day. Right. So you get a $3 fee per day. So if it's been 0 days late, then of course you have 0 days late fee. But if it's been 1 day late, that means 1 times what we got here. Oh yeah, $3. A $3 fee for 1 day being late will equal a total charge of $3, right? If it's been 2 days late, then it's 2 times your $3, which is equal to 6. And I think you see the pattern here. Look at what it's growing at every single time. 3s. So 3, 6, 9, and 12. This one's you could just leave it at 3 and 4. You could have picked any numbers, but I'm just going through those every single days. Okay, and there's your table representing a linear relationship. This is a constant slope, a constant fee per day. $3, $3, $3, $3, right? Now, using these points, I'll let you easily graph these. You could easily graph these points to make a nice thing. Please make sure to note, call this 1, 2, 3, 4. This is 0. And then over here, we have 0. This is 1, 2, 3. I wonder if it goes all the way up. Let me make sure. 5, 6, 7, 8, 9, 10, 11, 12. 12 is the highest. Checking over here. Yep, 12 is as high as you need to go. All of it should fit on your nice, pretty graph. Right? Or if you want to go more further, spread it out a little. Call that 1, call that 2, call that 3, call that 4. But it doesn't really matter. Just plot these points. You do the rest on that graph. Right? You do the graph. You could do it. That's the easy part. Moving down. Write a function for this relationship where y is the total late fees and x is the total number of days late. Now, look at that table. All right? Right now, your y-intercept is easy to find. All right, once you graph it, it's going to be even easier to find. You currently have a y-intercept of 0. There is 0 extra cost. The only thing that you ever have to pay is just the fee per day and nothing else. There is no y-intercept. The y-intercept is 0. So my equation is definitely going to start with y, which represents your total late fees, right? That you're going to be paying for whatever days there is. So how do you figure it out? Well, it's $3 since you're renting 4 movies times whatever number of days you have left, right? Whatever number of days you have left. This guy represents your slope, and there is no y-intercept, but if you really want to put it down, it's really plus 0. That's your y-intercept. There is no extra cost. But like I said, you don't really need it there, so you could just take them off, you know. Okay. A brief description, write a brief verbal description explaining this relationship. Well, I already said it verbally several single times. This is a linear relationship, right? It's a linear relationship, a positive linear relationship, has no extra cost. And in fact, this is also what's known as a direct variation because, well, it's a little part, honestly, we never went through, but it's pretty straightforward. I was hoping this problem would be a little tougher, but it's not. Pretty easy, pretty straightforward. Oh well. Alright guys, hope this video was useful. Was I recording? Good. Thank goodness. Alright, have a good one.